So nice to meet you virtually. It's said that we could not hang out offline somewhere, so I miss you guys. So probably the next DevDays we will be together. So now I'm in the middle of the forest in the border of Russia and Finland. So hope internet will work okay. So for those who don't know me, I am Nikolai Ryzhikov. I am CTO in Health Samurai. The Health Samurai is a FHIR company. So we are with the FHIR community since the beginning. So we contributed some open source stuff. Probably you know the Firebase. It's a database for FHIR built on top of the PostgreSQL. As well, we are doing the FHIR backend, 8box, for more than 4 years. And with our partners and clients, we build the FHIR first or FHIR native application on top of 8box. Today I want to talk about the collection of topics, the problems and solutions or tips which you may be useful when you go with the FHIR into production. And most of them are trade-offs. So what's wrong with the trade-offs that you don't have one solution, you don't have one aesthetic solution, and you have to sacrifice some features to get some different features. And most of these solutions I will show you, it's a trade-off solutions, and you will probably make different decisions, but I will show what kind of decision we did in 8box and try to explain why. And this may be helpful. So let's start. It will be split into the small sessions, and you can ask the question, and after each the small session and discussion of problems, I may answer a specific question about it. So let's go. The first problem. So let's imagine you build the FHIR server, you buy FHIR server, or install the open source FHIR server, and you want to load the data and to make your system work. And you want to load a lot of data, and you want to load the data quickly. And this is classical trade-off. So if you load everything in once, like create a bundle with millions of resources, your server will probably eat all the memory. So if you're gonna load it by pieces, it will take a long, and what's the bundle size, and should you run the validation, and when you should run the validation. There's a lot of questions, and there's one of solutions which we introduced for that problem. So first of all, we want to pick some streaming friendly format to load the data, and this is not the definitely JSON bundle. So one good candidate is an ND-JSON file. What's good about ND-JSON that you can process the stream of ND-JSON data, just reading line by line and processing line by line. So the general idea that we can try to build a pipe and stream the data from the source and write to the database without eating all your memory. And yes, so for example, in our case, we're using the PG copy protocol, which allows you to send the record by record into the database. Because of limitation of PG copy, so like validation indexes and stuff like this. So we do this into the temporal table. And then when this temporal table is filled, so we can run, for example, validation on top of this table. And then in one SQL transaction, we can do the insert select and move the data from the temporal table to the resource table. And to make the presentation a little bit more fun, so I want to show you how to work with this, some demonstration. So you can install, and I will show you with the DevBox. So DevBox is a developer version of 8box. It's free for development and evaluation. And you can get the license and just start the DevBox with a simple Docker Compose file. Okay, so now we're gonna import like one page of USMPI partitioners. So in a FHIR format, there is a project on GitHub when we convert the initial source of USMPI from CSV to the FHIR. And we have one page with 1K passions. So we're gonna do the monitoring the memory of our server. So that's why I use the visual VM. And So here I have an 8 box. So let's see in our partitioner table. I don't know who drew this figure. Can you remove this? I don't know. Okay, so we see that this table is empty, and we're gonna load the data, and we're gonna use this custom operation, which is called load. So, and you can provide a link to the file or to the URL. So usually we put this data to some bucket in a cloud, create a signed URL, and then you can share it. So, so let's start the import. We can go and see what's going on in the logs. So we see the temporal table was created, and now we're streaming the data from this file to the database. So we can go to the visual VM and see how it behaves. So it's increasing, but this is not so huge. Just try to load like a bundle with 1,000 of records into your server, and you will see the high spike for that. But now it's about the amount we're gonna load. So we are loading like 60 megabytes, and we see that it's kind of similar memory spent. So which means that we are very efficient, and we even can run the garbage collection in between because we are not accumulating the data. So this is just a common garbage in JVM. Okay, so let's wait a little bit. Okay, got it. So my laptop is overloaded, so we reloaded everything in 65 seconds. So, and let's see that we really loaded the data. For example, let's go to the REST console and just so we see the partitioners here. So we can go to the DB console and see how many, and it's 100,000 of resources. So, and it performs quite well. When I ran this before the presentation, I did it in 45 seconds, and which gives us like a couple of kilo resources per second, which is not bad. We use this feature a lot. And I think if you implement it on the FHIR server, you can do the same on your FHIR server, or you can use this with 8 box. We have a variation of this load operation to load terminology bundles into 8 box. It works very nice. So another kind of similar problem is what if you want to export a lot of data from the server, and we can apply the same approach. So, for example, the JDBC has a feature so you can create the cursor and take the data from the database in batches, almost like in a stream. And then we can just send this data to the socket, to the HTTP socket. And we can use chunket transfer encoding. This is extension of HTTP protocol. So because usually with HTTP protocol, you have to send the size of the response. But if you want to export the whole database, you don't want to calculate the size of this response ahead. So you can use a chunk and transfer encoding. So you just send the chunks with a size of information. And using this approach, you can load, let's say, a known amount of data. And the client can process this response in some smart way, like in a stream and putting it into the file, I don't know, somewhere else. So we call this operation dump, and we can play with this operation. So to start calling our server outside, so we have to go and create the REST client. So I already created one, so I call it CLI, and I allow the basic authorization into the secret, and I created the access control policy for that client, which is root access policy. We use engine allow. It just gives ability for this client to call any REST endpoint, but there is more fine-grained control in 8-box access policies using different engines. And now we're gonna try this stuff with the curl command. And yeah, let's export the same partitioners 100,000. So and we see that the data, we're receiving data right after the request. So that means they stream it from the server. And that's good. So if we just do it in a conventional way, we will have the freeze for some time when the server will accumulate the data, and then we get this data, and we will have a spike, memory spike for the server, and probably the memory can be exceeded. Okay, so we can see what's in this JSON file. So we get back, okay, it's too big, sorry. Yeah, we get the ND JSON data. So we have another nice variation of the dump operation, which is called a dump by SQL. So you can provide the SQL query and get the data through the SQL query. And for example, using this SQL query, you can flatten FHIR resources. In that case, let's just get the ID, the family, and the given name for the partitioner, and get in a tab separated format. So here we're running we're calling this dump SQL endpoint, providing the query, which I showed you, and we're piping this data into the data TB3. So let's do this, and we see that we got the stream of the data, and we can inspect what we got. So it's data CSV. So that's kind of useful operation when you want to export data into some business intelligence system or analytics system, or maybe feed it to some Python scripts for machine learning. And we see it's quite efficient. And we can connect the export and import operation and just pipe the data from one 8-box to another 8-box. And I hope other FHIR servers will implement this. And there is a bulk API documentation, and we implement it as well using these pieces to do this, but it's a little bit smaller than just bulk API. So, but it's very handy in real production. Okay, so maybe some questions about import and export and the streaming data. Yeah, I see one question.
Yeah, we've got one, it looks like. And the question is about for the load element, can you describe how you return results, status, resource IDs back to the client?
So when we load the data, so because we're doing the trade-offs and we want to load quickly, and in the 8-box, we allow user to manage the IDs. So you can send resources into the 8-box with your IDs. And in simple case, so we just using the IDs provided by the client. So that's why we don't have to return IDs back. The status, this is a synchronous operation. So you call the load, and eventually you get the response with the number of resources which were imported. So if it's, and this is everything or nothing operation, it's transactional. So if it's failed, then nothing is imported. And so sometimes we split it in two phases. As I said, we create this temporal table. And we have like a, oh no, not here. We have a variation of this import command when you just import it into the temporal table, and then you have a control over this data. You can validate this data, I don't know, maybe reassign IDs or fix some references, I don't know, even make some transformation. and then use the same insert select transaction to put the data back. So it's usually depends on the case, and I hope I answered your question somehow. Okay. So let's move forward. So most of performance problem with the FHIR, you will probably experience with the search API. And as with most of services, the search and the database is your bottleneck when you're trying to implement it efficiently. And the first kind of simple problem, not simply to resolve, but I call it count problem. So in the FHIR specification, you see that when you do the FHIR search, you get back the bundle with a total element, which says a number of resources which conform to this filter. You apply it, and the result can be paged. So the problem that to calculate this total, the server have to run two queries on a backend. And sometimes the counting query is even more expensive than the query when you're getting the data. And sometimes the user is not very interested in the amount of data, I mean in the total. And this is, again, this is trade-off. And we come up to the FHIR community, discuss this problem, and we've come up to the solution. So we introduce a count method parameter, or originally it was called total in 8-box, which can have three values like none, and if the total parameter set to the none, then the FHIR server not gonna calculate the total. Or you can set it to the count, or you can set it to estimate. I don't know, is anybody implemented the estimate version? So, and let's demonstrate this problem maybe. So let's like this, open the network. So we are trying to search, I hope you can see my screen, practitioners, which is starting with the DA, and paged by 10 records. So let's see what we get. So it's like half a second. Yes, it's not yet indexed. This is topic of the next small session. But now let's try to turn off the total. And we see that we got the response. Let me filter. In 10 times faster. So what the problem? So if we go here and we see that when we send this query first time, so we see the two SQL queries. The first, which is searching for the resources with some specific limit, and the second query just counting. So what nice with the limited searches, that database starting like a scanning table or index, and sending the records, and if it hits the limit, it just stops the feed. So this query can be finished earlier, but it's not the case with the count. So if the query is not very specific and you have multiple results, so the database have to scan the table or the index completely, go to the end to calculate the count for you. So, and yeah, this is trade-off solution. So, but you now can do this with 8-box. You can by default set the total to none, or default configuration still count. But if you encounter this problem, so look, maybe you don't need the total, then you can turn it off and just save one more query load on your server. Okay. Any questions about this? No questions. Good. Yeah.
Actually, one question about this. So, like, if you have estimate, how would you do estimation on number of rows?
Yeah, we're still curious how to implement this. So I was looking for the good solution. So the one of proposal how we can estimate the count using the PostgreSQL is just use the explain analyze query, parse it, because the Postgres planner in the database trying to estimate the number of results. It may be accurate if the statistic is fresh, or maybe not accurate, but we not yet really implemented it. But the one of possible solution use like a planner information, and it may be faster. So now in 8box we have only none and nothing. If you know the good implementation of estimate, you're welcome to share this knowledge with us. Okay. So,
okay, thank you.
Yep. So the next problem, yeah, it can be quite painful. So I call it like a deny of service of your database. So let me explain it. So usually you have like a database server which has let's say some amount of CPUs. So each connection to the database is usually processed in case of Postgres or the thread, and usually connection occupy the one CPU. That means that the number of and connection runs a query. That means that the number of concurrent queries on your database server roughly is limited by the number of CPUs. So, and maybe not for not very high load application, you can pick like 16 CPUs or maybe 32. The real high load use like hundreds of CPUs, but okay, but it's still the fixed number. And let's say we have a bad query, which is taking a long time. It's kind of easy if you have a lot of data, write the query, which may run like in minutes, hours, or even days. And with some like engines, when the queries are constructed dynamically, you can get it very easily. And so, and now the description of the problem. So let's say your client has these bad queries, user interface, and you have like 32 CPUs. So that means that, and this query will take 1 hour. And that means if the client will send you 32 such type of requests, then your database will like freeze for 1 hour. And how to deal with this operation. Sometimes you can just limit the timeout of the query on a database server. Just say that no one query should run more than like 10 seconds. But there could be problem with something like we showed, like export or import operations, which will probably take more time. So, and then the solution we come up, it's a timeout parameter. So to the search query, so we're using the GDBC, we're using the GDBC adapter, but I think other adapters can do the same stuff. So we have a default timeout. It's about like 1 minute, I think, but you can restrict it more to 10 seconds for all the search operations, or you can provide the timeout explicitly using the timeout parameter. And then on the server, so when we run the search queries, we put this timeout, and the GDBC runtime will just terminate the queries which are running more than the allowed amount of time. And okay, so that's real problem which can freeze your production for a long time, and you can just, you have to restart the services or stop all the connections. So, and you can guard it with something like timeout, and I will propose it to the FHIR specification, or maybe other FHIR implementers can do the same if they not yet did it. Okay, any questions about timeout?
It seems like you have a question around how do you calculate the estimate for count?
Yeah, we already discussed this.
Yeah, that's the one you tackled. Yeah, there's no specific new one then.
Okay, so let's move forward. Now this is well-known trade-off, and let's call it indexes problem. So the indexes are not free, and if you ever work it closely with a database, you know that you just could not index everything, and everything will work faster. Because first of all, indexes will take the space on your disk. That means more reads and stuff like this, and we will see the details of this problem. Another problem, the insert will slow down. So if you have a table with many of indexes, the performance of insert can be like 1 order of magnitude slower. And another bad stuff, that indexes are badly composable. That means if you have indexes for different columns and you have a query which you use both of these columns, it doesn't guarantee that both of these indexes will work together in a right way. So if you look into the popular FHIR servers, they have these problems multiplied. So the usual data layout for the servers like Happy and Wonk or the Grand server is that they have a resource table with a resource data. They have a search parameter table where the search parameter expressions are copied. And then they have an index. And usually the search table indexes indexed by default. That means that we store the searchable information 3 times. And in 8box, so we're trying to leverage the advanced features of the Postgres. So we store FHIR resources only once in a binary JSON, and indexes are optional. So you can build index if you really need it, but it's still the problem. So you could not just index everything because the performance characteristics of your server will go down. And how to solve it, nobody knows. So that if we look into the space of databases design, they solved it in very easy ways. They said that database not going to manage indexes. So I don't know databases which magically make indexes for you. So they push this to the user space, and the user is responsible to create indexes because the user know the load, know the profile of the of the load, and can make these decisions and trade-offs, create some indexes and drop other indexes. So, and we did the same with 8box. So we do not manage indexes, and the user can do and the user have to do these indexes by themselves. So let's do the small demo for that. So let's say, yeah, we already seen this query. So let's say we are searching for the data and we see it almost take like a second. If we run a second, it will be probably faster because database moves the data to the memory, but it's still slow. Okay, and so now we can create an index. So we showing you the SQL query, which is used for this specific search. And you can go and decide that you want to index this query. In our case, in our case, so we can, we use the so-called functional indexes, so we can index expression like a table, like a column. So we have this expression, and we're going to use a general inverted index and use the trigram options, which are going to speed up the I-like operation in a Postgres. So let's run it on our 100,000 of practitioners. It will take some time. Yeah, so the index is built. So then we can go back to the REST console and try the same query. So we see 100 milliseconds, and so we get to the tens of milliseconds with this query. And we can try to see what the real execution plan. This is another custom parameter which you can provide to the search to see how the query was executed, and we see that we used the database uses index to do the search. Okay, but yeah, index is not for free, so and they have a cost. So let's go and see So for example, let's see the table size. Yes, something like this. And let's uncomment this. So here we see that our table with the partitioner is like about 100 megabytes, and the one index is used like a 10 megabytes. It's just 10 times less than the our data. So if you imagine like a tens of such indexes, and we used very compact gene index. In most of cases, like indexes like B3 is even bigger than this index. So you can imagine, and you've seen how much time it took to build this index. And usually if you rebuild the index on each insert, it's even slower because the bulk building of the index is faster. Sometimes it's even worse to just drop all the indexes, bulk load the data, and then build indexes again, then loading the data into the indexed table. And you see that how size of indexes can reach even be bigger than the size of your data. So this is trade-off. You have to think, and there's different types of indexes which suitable for different situations, and we will see some examples further. So, okay, so this is index trade-off. The solution is just allow the user manage indexes, and we see how it works. And we're just helping from 8box to build these indexes. Okay, so any question about indexes trade-off? No questions. Okay, how much time do we have?
There are a couple of questions that came in, and the last one is about indices. So it's for the problem of being badly composable. Is the collision of the indices part of it?
You mean about the indexes composition, yes? The question.
Yes, I think
this is the topic.
Yeah,
this is the topic of the next small session. Okay.
Wonderful.
So let's look at this problem. So we're trying to search by multiple criteria. Let's say like this. We're going to use just explain mode. So that let's pick the REST console. Without index, we just see the sequential scan. Yes. And then we can go and build 2 indexes. Let's say one index for each criteria. Okay. So we build these 2 indexes, and then let's see our execution plan now. So it indexes, but it do some additional stuff, like he's doing like a merging the 2 index scans. It's like a joining. So, and in that case, both of these indexes are B3, so they can be joined. Sometimes if they're different type of indexes, that not happens, and that bring us the not always indexes place together very well. So at least the performance dependency is not linear on the indexes, and sometimes there is a solution for that problem. Which can be applied. It's called, oops, no. It's called multi-column or the compound indexes. So, for example, I can just show you, I have only 5 minutes. So, I'm gonna speed up. And so we can build like a compound index using both expression, the one index. 2 columns for 2 elements. If we build this compound index and then run the query again, we see that we hit 1 index and it's executed much faster. So this query is going to be executed much faster. And that means that sometimes if you always use the same search parameters in the same order, it may be worth to build this compound index, and this index will outperform the two indexes for both of these columns. Yeah, database designers, developers trying to fight with this problem, so and we see some progress, but sometimes you still want to do this. And I even say even more strong statement that in real high load systems with a large amount of data, the only way to make efficient queries is a hit only one index. So if you have a really loaded system and very popular query, so the only way to do to make it work fast, like in 10 milliseconds, is just to make one index for all the queries. Probably make different index for different type of queries, but it's probably going to be compound indexes which take into account like sorting and stuff like this. So and this is the next topic, which is without the demonstration. So if you go to the chain parameters and joins in database, so that if you really have a lot of data and you want to get the good performance, the joins and sort just kill your database performance. So the only way to do this is have one index and one table. And the common solution from the DBA side is just do the denormalization. So instead of doing the join on fly, you just put this data ahead. So it's called denormalization. So for example, in 8box, so in a resource, in a reference type, data type, so we have a resource element, and you can put some elements of the reference at resource. And then you can build the index on this specific resource and searching by the data from another resource. But you have to pay for this normalization. You have to keep it consistent. You can use subscriptions or like a periodic SQL jobs to update this stuff. So what's nice trick which we really use that you can run the bulk SQL updates. This is a sample of the bulk update, which just do what we see, that it copies the birth date to the encounter table. And what's nice, it's really performance, so it can run in the minutes for the millions of records. So, but it's not real time. So, if it's not critical for you, you can run similar job like in 10 minutes, hourly, or maybe daily, and it will work fine. If the data don't change quickly, like birth date of the patient, so the probability that it will change kind of slow, but sometimes you want to add more attributes and stuff like this. So, and this is complicated problem. So we are thinking maybe provide some DSL where you can describe what kind of denormalized elements you want to see in the references, and 8box can do this job for you. Oh, and I'm out of time. So you see the presentation and you have my contacts. So if you have questions about this, so I can just quickly go through. There's a multidimensional search, which is common trade-off. So no databases, I mean relational databases, can do this efficiently. And we have some hack to work with it. We just split it into different queries. Sometimes you can get the right performance only by rewriting the SQL. That's why we introduced some SQL on FHIR. And we provide like meta resource 8box query when you can provide the template as a SQL query, which can be parameterized and then can be exposed as a parameter or in search or as a separate endpoint. And the problem with this stuff that it's not composable with other params, so we come up with a second version, which is called the search query. And this is when here with this DSL, we describe the parts of the query and then the engine build it. And now it can be composed with a FHIR search parameters like count, total, and other. And we are working on the third version. We want to get in 8box a composable search parameter with a highly flexible SQL, which you can override for even for specific combination of parameters. It's complicated, but it's really needed for real life. Okay, I think I finished almost in time. And I don't have any time for the questions, or I have some time.
Well, thank you, Nikolai, and I always hate rushing people. Omar, I know you were asking some questions. I'm not sure if there's additional ones out there that you never got to. We can certainly spend a couple of minutes addressing those.
Yes. We do have another question coming in about if multi-threaded queries are not available, have you considered table partitioning or filtered indices?
Yeah, so it's possible. So if you really have a lot of data, so the common approach in Postgres, just split this table into partitions. And so we have already some multi-threaded queries in Postgres. So it's available since version of F11, I think. But you can physically partition the one table into different tables. And this can definitely speed up your query. If even some criteria can reduce the number of partition to query, it's even better. There's such approaches like partial indexes. And so there's a lot of stuff. I don't know. Probably we can make a QA session, and I will show you other tricks how to make it work.
Nikolai, we did have one other question. Let me know if you tackled it earlier, but this one has 3 votes. How many resources are in the database you're querying? And what is the largest data set you've tested against, and what is the relative performance?
Okay, so we did some synthetic stuff, but if you're talking, so for now, we were working with 100,000 of practitioners, all these queries and import and export. So in real life, so I think the biggest real production we implemented, it's like 2 million of patients. And this is like one state HIE and EHR system. So 2 million of patients, I think it's billions of resources. So, and we did some synthetic tests on the 1 terabyte of data, which has like 10 million of patients filled with the Cynthia data. So, but what I can say, starting from some size, you definitely need experienced DBA who will help you to go through all of these problems. As I show, you can easily DDoS your service with just one slow query, even if it has like hundreds of CPUs. Just one query can kill everything. So, and this is always, yeah, it always needs some professionals to work on load.
Okay, thank you, Nikolai. Thank you, Omar. Thank you, everyone. So we are done with this session. Enjoy the rest of your day.
Thank you, guys. Bye.